Hi, Dr. Pat here. We're looking at logistic functions, and in this example, we'll be solving a logistic equation. So basically an equation that we made up using a logistic function. Okay, so let's take a look at what we've got. We've got Kaylin. She's doing a fundraiser for her Girl Scouts, and she makes some logic puzzles. And so she's selling these books. Initially, she sells 25 books. Looks like sales are really going well, doubling every 6 days. But she expects to sell about 5,000 books. That's what the market's going to take. So we have logistics situation because we have a doubling idea, which is normally exponential. But because we're having a cap here, we've got indications that we'll have a ceiling of 5,000 books. We're looking at a logistics model. So it's kind of cool that a logistics model is just a variation of exponential with a ceiling. Okay, so that's what we're playing with. And the model that I created out of this information is right up here in the top right hand corner. So now how did I get this model, you might be asking? Well, what we have is we have a saturation mark. We have a ceiling of 5,000, and the ceiling is basically our numerator value. We are doubling every 6 days, and so doubling is a 2 to a power, and because it's taking 6 days, it's 2 to the 1/6 power raised to the t. So basically, doubling situation is power 2, I mean 2, base 2, exponential, base 2, doubling. If it was tripling, you would have a base 3. We have a doubling, so it's base 2, and then because it takes 6 days to double, then it's 2 to the 1/6 power. And so that's what I have here as the base of my exponential. Because the logistic models very early on follows the exponential model until it starts curving down. So that doubling every 6 days is an exponential model. That's what happens initially. That's what we see in our logistics model. So that's where that 2 to the 1/6 coming from. And then where did this 199 come from? Well, basically, we're looking at an initial value of 25. So I set 25 equal to the y, and then I've got 0 for my t value. When we do that, the 2 to the 1/6 to the 0, that goes to 1. And then we have 1 plus a. I do a cross multiplication. So I bring the 1 plus a over to the left side, divide both sides by 25. That's where you're seeing this 200. And then subtract 1, and I got my a value. So that's basically what I've done with here. That's how I developed this formula, just using the characteristics of the logistics function. There with the ceiling, the initial value adjustment number there, 199 is not my initial value. It's the number that calculates, that gets me my appropriate initial value, and then how things are growing initially at the very beginning. And so then when we do this, basically what I'm going to do is take this logistic model, set it equal to 2500, and we'll figure out the time, and our answer is 45.82. So now, how did I get that 45.82? Well, let me show you the algebraic steps of how we got that. Okay, first thing I do is I make my equation. I set it equal to 2500. And then my next step is I'm going to do that cross multiplication. I'm going to bring all this stuff out of the denominator, bring it up to the left-hand side, and then bring that 2500 down. I'm looking to solve for t. That means I got to get t out of the denominator. Okay, so I'm cross multiplying to get the t out of the denominator. Then the next step after that is, oh my gosh, what happened here? Oh, this 1 right here. See, I'm solving for t. I got to get rid of this 1, got to get rid of the 199, and have to get rid of this 2 to the 1/6 kind of situation to get t out of the power. So first step, let's get rid of the 1. I bring the 1 over by subtracting 1, and then also work this fraction. When you do this, you get 5,000 divided by 2,500. That's 2. Subtract the 1, and that's where this 1's coming from. So it's 2 minus 1 here. Next stage is let's divide both sides by 199. Pretty straightforward that way. And then the next thing we want to do is get rid of this kind of thing. Now, we've got to work the exponents, and one thing I'm going to do here is that negative power, I'm not liking it, so let's do negative power to both sides. And when you start with the fraction and do a negative power to it, you kind of get rid of your fraction, or you flip the fraction. And then also the powers here, whenever you have a power to a power, you multiply the powers, and t times 1/6 is the same thing as t over 1/6. So that's what I did there. Okay. Next step that I'm working on is I'm going to take the log base 2 of both sides. So I want to get rid of this exponential so that I can get t out of the exponent. And one way to do that is log base 2. So I do the log base 2 of both sides. Why? Is because those two pieces will cancel out, will leave us the t over 6. Okay, so I got the t over 6 now because the log base 2 and base 2 exponential cancel out. All right, last step, looks like we have to get rid of this 6 here. So it's dividing t divided by 6. Let's multiply both sides by 6. And that's what we've got. And you may notice on your calculator, you do not have a log base 2 on your calculator. However, we can change the base. And the technique for changing the base is convert it into a logarithm that you can use. I'm doing ln in this case. And so what's inside the logarithm goes into the numerator, so the ln of 199, and the base there, that log base 2, that goes in the denominator. A really dorky way to remember this, and I do admit this is dorky, when you're doing the change of base, just remember the base goes in the basement. Yes, that's right. The base goes in the basement. Put it in the denominator. So if you ever wondered, which way do I remember? How do I remember 199 on top or the bottom? Just remember the base goes in the basement. And then when you crunch this out, you get the 4582. And that's how I got that time when Kaylin sells half of the amount that she has. She sells 2,500 of those logic books. Okay, hopefully this was helpful. Talk to you later.